strength of materials. Strength of materials. Okay, I will go. This is actually theoretical knowledge, because it will help you to understand, to more clear of strength of materials. That's why in my problems channel I want to upload this type of theory, because it will help more and more for understanding the problem. Gradually I will upload for this. For getting this, you should subscribe this channel. Okay, let's start. Strength of materials. Actually, what is the materials? We know the materials. If you consider this was the materials, this one is the materials. Actually, there is the lots of particle. That means it's a solid. When we is for this strength, if you want to measure this strength, we have to apply force, right? Any sides or any portion we can apply the force, right? Force. So this is the actually our main recommendation of this strength of materials. After applying this force, how much can deformation or how much can sustain on that surrounding or environment, that is our main purpose. Okay, so we have to know what actually the physics term of force. Actually, what is the force? What is the force? Actually, force actually change of motion. You can say change of motion. Change of motion, that means when it is applying the any motion, when will get it will reach in the surface, it will change the motion. Okay, it can accelerate or disaccelerate or stop, this type of. That means main is the change of motion is the force. Just remember this, because it will help to understand the next point. Okay, next, then we have to know, if we know the force, when we apply the force, this materials, wait, when we apply the force in these materials, then what will be happen here? It produce the we produce the stress, right, or pressure. We are familiar with pressure, but we are the stress. Actually, what is the difference between stress and pressure? Actually, when it will act in inside will be changed, inside elements, structure, or this type of will change, then we can say is the actually is the stress. When it will the external change, then we can say is the pressure, right? Suppose we know the Pascal formula here. We know that is when give the pressure, it will pressurized increase in the every section. This means is the externally change is called the pressure. Okay, actually after this we have to know what is actually different terms on strength of materials, different term, because this materials, if I draw again, okay, this actually different terms here. When you apply the force, this it can be actually axial force, when it will apply in axial force, and also axial force we can say, and also another we can say the bending force, or it can bending moment. When we apply the force, if we is fixed in, it can deliver array, it can deliver beams like this, and then if we apply here force, then it can bend in the this you can say bending moment, right, right. And it was axial force, and that was bending moment force, you can say bending moment force. Another, when you apply this force, it can break down. It's the breakdown. There's an actually shearing force that we can say shear force. Okay, I think it's clear. The axial force and bending force, bending moment, and the shearing force. I think it's clear. Okay, next. This is actually is the we can define the this is stress in different types of like if we say is simple stress, right? Simple stress. What is actually the simple stress? And we can say in mathematical way, and applied. You can say the applied force divided by in resisting force. I can say resisting force, right? We have seen here in before there is the applied and resisting force in resisting in area, resisting in area. This is in area. This is the apply. This is the apply. This is the area. Okay. This is applied force. Applied force means applied area. Okay, applied area. There is the three types. You can see. One is the normal stress. One is the normal stress. And another is the actually is we can say shear stress. And another is the bearing stress, right? Bearing stress. Okay, actually what is called normal stress? We know simple stress, or what is called the normal stress. Actually when we apply, if we consider this one is the cylindrical, is the shaft, this one is the surface, and if this, it can be tensile or compressive, it doesn't matter, both it can be compressive, but it will create the surface. According to surface, it will be 90 degree. Then we can say is the normal force, right? I think it's clear. Another, also this one is the cylindrical, but we applying the force that after applying force, it has been cutting, it has been shear means you can say the cutting. Okay, this force and cutting force actually is the, if I take another color, and this one is the, you can say this one is the is parallel, this one is parallel, right? This on is parallel force. Then we can say this is the shearing force, right? Okay, I think clear. And then bearing stress. This means contact pressure, actually contact pressure when between two bodies. We can say that this one is the, if we draw again, is the nut and bolt. Maybe we are familiar with nut and bolt, and this is the contact between two, this surface and this surface is contact point. These two surface contact pressure between two bodies and these bodies, and this pressure, these bodies. This is the bearing force, because this force is bearing on that surface. That's why we can say this is the bearing force. For example, we can say here this one, when we pull any, if we say any roof we pull, and then it creates this normal stress. If any man is pull or pushing, then it create the normal stress. And is the shearing stress when you cut any paper with scissor, is the paper with the scissor, and then it create the is the shear stress. And bearing stress, when we do any type of tight wrench by using wrench, then we create the bearing stress. So suppose we know the nut bolt joint, like a belly breeze, or there has the attached two path by nut and bolt, and that we use the bearing stress, bearing shear, bearing shear stress, bearing stress, sorry, bearing stress, right? Okay. Another last one is the last one. Another way uh, we can define, or we can away uh, you can distribute this normal stress, normal stress, normal stress, two types. Another way we can say the normal stress, two types. Number one is tensile stress, tensile stress, and the compressive stress, right? We know when we apply in the this direction from object to outer part, when we'll pull, and then we can say this one is the it is create in the tensile stress, and this one is the when we push anyone to compressed, and then we can say it's in the compressive stress. Okay, today's until this. If you have any confusion, you can ask in the comment section, and next time I will I will do this type of video if you're interested. Thank you for your passion. Thank you. Thank you.